Hey, happy Friday everyone, and welcome back into the Wells Tech Garage for this month's episode of TechConnect. I got a lot I want to talk about today. We're going to discuss the stuff from our last class where we covered the mass airflow sensor case study. I have a couple sensors in front of me here. We talked about cleaning those sensors, so I have some data from those. I'm going to answer the question to the t-shirt giveaway, and we're also going to announce the next class. So without further ado, let's get right into it. I'm going to start today with the t-shirt giveaway question, and I was a little bit surprised at the variety of answers that we got on this. And I think a lot of it was because of the way I worded it. It should have probably been worded better, and also I should have had it up on the screen for you guys. So I apologize for that. The next class will have it up on the screen for you, and it'll be worded properly. The question was, an engine has a stuck-open purge solenoid. Okay, Technician A says that this could cause a rich condition. Technician B says that this could cause a lean condition. Now we had answers kind of all over the board. The correct answer is both. A rich condition because what is our purge solenoid doing? It's connected to our intake manifold, stuck open. It would draw vacuum on the evap system down the hose to the charcoal canister. If that charcoal canister is containing vapors at that point, those vapors would be drawn up into our intake manifold, and the PCM is not commanding our purge solenoid at this point. Say we're just at idle. Our purge solenoid is stuck open, drawing those fuel vapors in and causing a lack of oxygen past our oxygen sensors, right? We're polluting that with excessive fuel, okay? The oxygen sensors are reading a lack of oxygen, giving us a rich condition. Technician B is also correct, because if that purge solenoid is sitting there in the intake manifold, drawing all those vapors out, what happens when that canister doesn't have any vapors in it? What happens then? Well, our vent solenoid, which is after the canister, is open to fresh air all the time. So if we put vacuum on this side, we draw all that fresh air in through the system into our intake manifold, causing an excessive amount of oxygen past our oxygen sensors, creating a lean condition. So the answer to the question is both technicians. Okay? Now, let's talk about all those comments and questions from you guys. On the 11 o'clock class alone, I believe we had something like 254 comments. Who's counting, right? This is amazing. You guys are talking not only to me, asking me questions, which I love, but you're also talking to each other. I believe New Level Auto, I believe you said that you were stirring the pot. I love that. Let's get everybody thinking. We're a group, a community of technicians and do-it-yourselfers and whoever wants to learn. Let's get everybody in here talking, chatting back and forth, building this community with each other, because that's what it's all about. We can help each other have a better day. So we had some comments in here that I just wanted to address. First of all, I was probably bright red in the face. The whole comments on the yoga pants thing, we're not going to be selling or giving away any Wells yoga pants, unfortunately. We're just sticking to the hats and t-shirts at this time. So I was probably just bright red in the face when we were talking about that. So if you missed that, the 11 o'clock class had the yoga pants comments in there. And then Mike Burton came on and he said, "Great job, Mike. Is there any links to buy some Wells swag?" Well, right now, currently, there is not. The only way to win the awesome Wells Tech t-shirts or Wells Tech hats is to earn them through answering the t-shirt giveaway or Wells swag giveaway question, okay? So, Mike, I hope that answers your question. You cannot purchase, you can only earn right now, okay? Bax Rock 2 came on, a lot of comments from you. That's really awesome to see, I'm glad. But you were talking about checking voltage on the mass airflow. I think by the time we got to the end of the class, you realized that the GM mass airflow sensor we were working with does not output voltage, it outputs a frequency. I think you were more in line with used to testing of the Ford Mazda motors where they will output a voltage level. Our GM digital sensor will output a frequency between 0 and 5 volts that changes frequency depending on airflow. So I hope that that question was answered, Baxrock 2, in the class itself. New Level Auto came on. He said current can make you nuts. Only micro amp clamp is somewhat definitive. And this must have been the point where I was clamping the power wire going into the mass airflow to show you guys that the current draw would increase as we're trying to keep the sensor element inside hot. And New Level Auto is 100% correct. And like I talked about in the class, this isn't something that you would normally do. I just wanted to prove a point on how the sensor functions for you guys, but I don't think I would ever be throwing an amp clamp on a mass airflow sensor, okay? OzStar came on and said, now I have to try that 80% rule. And that's something that I've been playing around with a little bit here, and I've found that it's pretty accurate. That's that 80% of your vehicle horsepower should be roughly your mass airflow grams per second. I've seen that it's pretty accurate so far. I don't know that I would use that as my only justification, but I think it is something interesting and something that kind of helps maybe move things lower down the list if you're on your diagnostic checklist, okay? So, all right, let's segue into the mass airflow sensors themselves. Now, I talked about during the last class, we have the one out of the Colorado here. I also showed you guys that I had another one. I believe this was out of our GTO. Both sensors were dirty. Both sensors were problematic. So what did I tell you I was going to do? I said I was going to clean them. So here, the Colorado sensor I cleaned with mass airflow sensor cleaner, and the GTO sensor I cleaned with brake clean. If you remember from the last class, we talked about the different cleaners and if you should clean them or if you shouldn't, and what carb cleaner does to them. And we kind of determined mass airflow cleaner and brake cleaner were kind of the way that you would want to go. So that's what I did. I took and sprayed them down and took some images on the microscope. Okay, so as you guys can see up on the screen here, we got our sensor just like it looked when we took it out of the Colorado. I showed you guys that picture. It was all caked with dirt and grime and could possibly be tire material. And here's what it looks like at 100 times zoom after being shot with some mass airflow sensor cleaner. And now, I didn't go use half a can of cleaner on this. I sprayed a decent amount, what I thought was enough. I sprayed it down, and you guys can see that it's definitely cleaner. You can see here at 150 times zoom that the sensor has less dirt on it. But look at this thing. Look at our coating on here. Remember, these sensors have that clear coating over them, that non-stick coating. Looks like this thing was sandblasted, right? Here, I can kind of zoom in on this a little bit. But look at, like, right in here, you can see that thing is just beat up. The coating itself is just beat up on there. So does cleaning our sensor with cleaner, does that really take care of the problem? Is it really cleaning anything? Is it really bringing our sensor back to new operation, back to fully functional operation? I would say no. I would say this sensor is still not where it should be. I don't think this sensor could ever be 100% again. Our coating is no longer intact. The sensor will fail and will fail more frequently than it did before. So I don't think using mass airflow cleaner on our sensor here, I don't think that took care of it. So in my opinion, the best way to do this would be to replace the sensor. Now, let's look at our GTO sensor, this one right here. I cleaned this one with brake clean. So here's one of the elements before cleaning. This definitely looks like tire material on here. New Level Auto, you might be onto something here. So here's before cleaning, and here's after cleaning. And again, this was brake cleaner. I sprayed a good amount on there, what I felt was enough. And after I saw this, I tried to spray more and still couldn't get this stuff off. So again, cleaning the sensor, did it solve our problem? You can see the sensor is just still full of gunk. Go on to the next picture. Here is the other element inside of the one for the GTO. You can see beforehand it was all full of what looks like sand and dust. Afterwards, it looks like the thing was sandblasted. Our coating is no longer intact, okay? So long story short, is cleaning of the mass airflow sensor worth it? I could put this in the vehicle. It would probably work today. Is it going to work 100%? Are we going to hit that 99% load? Are we going to hit that 185 grams per second? I don't know. Maybe today. But now our sensor's non-stick coating is off of there. Stuff is going to stick to this thing. It's going to fail again. I don't know if it's going to fail tomorrow. I don't know if it's going to fail a week down the road. It's hard to say. All I know is this sensor is not 100%. It's not like replacing it. So again, the option is really up to your customer, but if you ask me, judging by these pictures here, is there really an option? You don't put new ball bearings in a wheel bearing, right? You don't do that kind of thing. Why does cleaning a mass airflow sensor, why is that something that's even possible? The element's damaged. I mean, look at this picture. This element here is damaged. So, in my opinion, the best way to fix the vehicle would be to replace the mass airflow sensor, and that's going off of the evidence that I have here in front of me. Now, when replacing the sensor, you've got a couple options. You have one like this, which is a reman sensor, or a brand new sensor. So there's a price difference, obviously, rebuilt versus brand new, but is there a difference with the elements themselves? What is a rebuilt sensor? Well, here's our reman, here's our new sensor. They look completely different. What the heck is this thing? Our element is coated in something blue. I would assume this is our non-stick coating. Our element here is actually bent. This is kind of weird. It's kind of skewing the location of this, which could potentially affect the air flowing past it. And it just doesn't look like our new sensor, which looks exactly like the sensor we pulled off. Our elements look exactly the same. All right, so here is the outer element on the reman, and here is the inner element. They look nothing like the original. This one kind of looks like the original, just like it had some blue whatever sprayed on it. But this one, this is something else. We lost surface area here. What about this section and this section for surface area? Is this sensor going to respond the same? The other problem I saw with this, if we bring this into 200 times magnification, look at all these bubbles. See all these bubbles in here? That's in the coating. What is that doing to the minuscule amount of current that this sensor is using? Is this thing reading accurately? It just, to me, it doesn't look right. We didn't see any bubbles in the clear coating that was on the other one, on our brand new sensor, but this definitely has bubbles on it, and you can see our sensor element in here has this coating over it, but still, we're losing surface area on our inner element. Here is something that's a little bit interesting. Here is our our reman joints where the element here is soldered to the side piece. Well, here's where the old one sat. You can see it's kind of looking a little, I don't want to say rusty, but potential place for corrosion to build. And it just doesn't look as clean as our brand new sensor. This is really pretty, looks nice. It's going to be a good connection for a long time. This has me wondering, how long is this thing going to last? So what did I do? Throw it in the vehicle, right? Take the reman in the vehicle versus the new in the vehicle. So when we had the class last time and we verified a repair, our new sensor peaked at 185 grams per second at 99% load. Pretty good numbers. So what does our reman sensor do? Our reman sensor peaks at 180 grams per second at 98% load. So fresh, out of the box, brand new, just done today, this sensor is reading 5 grams less per second, right out of the box, than a brand new sensor. So I'm just going to leave you guys with that information. You can formulate your own opinion, but as a technician, as somebody who wants that vehicle going down the road when it leaves the shop 100%, I can tell you guys what part I'm going to put on. So keep that in mind when you're when you're out there dealing with mass airflow sensors, okay? So I think this was some good information on mass airflow. Tell me what you guys think, maybe some of your experiences. I'd love to hear if you guys have been successful cleaning sensors, if they've taken care of the problem long term, or if it seems like every sensor you clean seems to be coming back in a month or 2 or 3 and the customer ends up buying a new sensor at that point. Anyway, so let me know what you guys do in the shop, okay? And I know a lot of us, it does depend on the customer, but I'm just curious what you guys do, what you guys recommend, what you guys see out there in the shop, okay? So let's get on to the next class. Our next class, June 1st, next week Thursday, 11 a.m., 2 p.m. Central Time. We are going to be starting a new kick on evap. So yay, we can all cheer that we're not talking about fuel trims anymore. We're going to start talking about evap. And the reason I want to talk about evap is because, for one, it seems to be a confused system. It seems there's a lot of confusion surrounding evap. We get a ton of calls on evap on our tech line. Everything from basic of where is my vent or purge solenoid to how do I find a leak? Why is the computer setting this code? Why is it doing this? Why is it doing that? So we're going to get into the evap system, and it's not just going to be a one week class here. We're going to space this out over a couple months, and we're going to go beyond the leak. So we're going to go into purge and how the computer reacts. We're going to give you guys some tips and tricks, and then we're going to expand on it. We're going to go from the basic evap standard purge vent system. We're going to bump into the other systems on Europeans, on the Asians, on the Chryslers. We're going to get into all those other systems. We're going to talk about them. We're going to find out how they function, how to test them, the kind of intricacies of the system. We're going to look into all that over the next few months. So hop on the bandwagon for evap. Next week, June 1st, 11 a.m., 2 p.m. Central Time, we're going to be starting on our evap class. All right, so I think that's going to be about it for me for today. If you guys like what you see, please give us a thumbs up, share the video, like the video, comment, let me know what you guys think. You can always send me out an email. My email address will be below here in the description. Oh, the survey. We have about a week left on the survey. June 1st, we're going to be ending the survey. So we have, if you haven't taken the survey yet, please go out there and do it. It just takes 2 minutes, seriously. It is super fast. I believe it's 6 or 8 questions for you guys. Just kind of for me to get a feel of what you guys think of our training and that kind of thing. And then you could also, or you are also, if you complete the survey, entered to win one of these awesome shirts. So the link for the survey is also down below here in the description for the video. Okay, so check us out social media, Facebook, LinkedIn, Instagram, Twitter, and if you're not already subscribed to our YouTube channel, please do that so you get updates from us. And all right, so I hope everybody has a great weekend, and I hope to see you all on June 1st at 11 a.m. or 2 p.m. Central Time. So thank you guys, happy wrenching.